January 1971, somewhere over northern Vietnam, the sky was low, heavy, and hostile. The B-52G Stratofortress, call sign Iron Lantern 04, was not supposed to be there anymore. Its bombing run over the Red River Delta had been completed minutes earlier, payload released on coordinates fed from Guam and relayed through layers of command. The aircraft should have been turning south, climbing back into relative safety. Instead, it was dying. A North Vietnamese SA-2 guideline missile had detonated close enough to rip through the bomber's left wing root. The shockwave crippled hydraulics, shredded wiring, and knocked two engines offline. Fire alarms screamed across the cockpit. Smoke filled the lower deck. The crew reacted with drilled precision, but this was not a fighter. The B-52 was a flying city, and parts of that city were now collapsing. Captain James Holloway, aircraft commander, made the call no B-52 pilot was trained to make. "We're not making it to the coast." The standard procedure was clear: bail out over friendly territory or the sea. But the Stratofortress was still airborne, still controllable, barely. And below them lay jungle, river valleys, and scattered villages. Against doctrine, against instinct, Holloway chose to descend. What followed would never appear in official American records. The bomber limped southwest, losing altitude, dumping fuel, its massive wings flexing unnaturally. North Vietnamese radar stations tracked it in disbelief. No B-52 had ever attempted an emergency landing in the north. Fighters were expendable. Bombers were not. At 3:17 local time, Iron Lantern 04 crash-landed on a crude emergency strip near the outskirts of Thanh Hoa province, an auxiliary runway originally built by the French, long thought unusable. The landing gear collapsed on rollout. The aircraft skidded, tore through dirt and concrete, and finally came to rest tilted, wounded, but astonishingly intact. The crew destroyed what they could. Classified documents burned, radios smashed, explosives detonated unsuccessfully in damaged compartments. Within minutes, North Vietnamese troops surrounded the aircraft. For the first time in history, an American B-52 had been captured largely intact. Hanoi understood the significance immediately. The Stratofortress was not just an aircraft, it was doctrine made metal, a symbol of American industrial supremacy, nuclear-capable, intercontinental, stuffed with electronics, radar systems, electronic countermeasures no Warsaw Pact engineer had ever seen firsthand. The order came from the highest level: secure the aircraft at all costs. Over the following weeks, under camouflage nets and constant threat of American airstrikes, Vietnamese engineers stabilized the airframe. Soviet advisors were flown in quietly. Crates arrived by night. Sections of the bomber, radar modules, avionics racks, ECM pods, were carefully removed, cataloged, and prepared for transport. The airframe itself could not be moved easily, but the brain of the bomber could. By March 1971, under a veil of diplomatic silence, the most sensitive components of the B-52 were en route to the Soviet Union, officially listed as industrial machinery. Unofficially, it was the most valuable intelligence prize of the Cold War. Zhukovsky Airfield outside Moscow, late April 1971. Colonel Viktor Andreevich Sokolov stood alone in Hangar 12, staring at something that challenged everything he thought he knew about aircraft design. Sokolov was not impressed easily. A veteran test pilot and engineer, he had flown MiGs from the early swept-wing days through the MiG-25. He understood speed, altitude, simplicity, and brutality. Soviet aircraft were built with a philosophy he trusted: survive, intercept, return. The American bomber before him felt alien. It was enormous, inelegant, almost obscene in its scale. Wiring harnesses thick as a man's wrist, racks of black boxes stacked like furniture, redundant systems layered upon redundant systems, all interconnected, all dependent on each other. "This thing is not an airplane," one engineer muttered. "It is a flying factory." Sokolov said nothing. He walked slowly along the disassembled radar assembly laid out on steel tables. The AN/APQ-109 bombing radar. The AN/ALQ-117 electronic countermeasure suite. Each component labeled in English, still smelling faintly of burned insulation and tropical humidity. American engineering philosophy revealed itself immediately. Dominate through complexity. The briefings had warned him. The B-52 was designed to penetrate Soviet airspace, confuse radar, jam missiles, absorb damage, and still deliver its payload. It was meant to fight through layers of defenses, not evade them. But standing there, Sokolov felt something unexpected. Not fear, vulnerability. The first systems analysis lasted weeks. Soviet technicians dismantled modules with surgical care. Some circuits were brilliant, others were fragile. Many relied on maintenance standards and logistical support impossible to guarantee in wartime conditions the Soviets planned for. Sokolov recorded his impressions in a private notebook, separate from official reports. The Americans assumed control of the environment. They assumed clean runways, uninterrupted power, trained specialists. This machine reflects that assumption everywhere. What fascinated him most was not what the bomber could do, but what it required to do it. Entire teams were needed to keep one aircraft operational, specialized tools, constant calibration, climate-controlled storage. A failure in one system cascaded into others. By contrast, Soviet bombers were crude, yes, but autonomous. Sokolov requested permission to sit in the cockpit section that had been shipped intact. When he climbed inside, the sensation was overwhelming. The cockpit was spacious, almost comfortable, seats padded, instruments dense but logically grouped, warning lights everywhere. "It flies with committee approval," he joked dryly, yet he could not deny its power. This was an aircraft designed to project force across continents, a machine that assumed it would always have time, fuel, and support. The question forming in Sokolov's mind was dangerous. What happens when those assumptions fail? By June 1971, Soviet leadership authorized the next phase, simulated operation. They would not fly the B-52, too risky, too visible, but they would recreate its combat environment, electronic warfare tests, radar exposure, missile engagement simulations. Entire air defense regiments participated, and slowly a pattern emerged. The bomber was formidable when everything worked, but when systems degraded, when interference stacked, when damage accumulated, its effectiveness dropped sharply. Not catastrophically, but predictably. Sokolov summarized it in a classified briefing. "This aircraft is not resilient. It is persistent. It relies on overwhelming capability to delay failure, not prevent it." That distinction mattered, because the Soviets did not fight wars of delay. They fought wars of collapse. Late one evening, alone in Hangar 12, Sokolov stood again before the captured components. He imagined the bomber over Soviet territory, nuclear payload armed, electronic warfare screaming across the spectrum. And then he imagined it alone. No support, no repair crews, no replacement parts, just metal, fuel, and time. He closed his notebook. The Americans had built a giant. But giants, he knew, fall hard. The weight of assumptions. July 1971, Moscow. The classified briefing room beneath the Ministry of Defense was windowless and cold, deliberately so. The air smelled of paper, dust, and stale tobacco. Colonel Viktor Sokolov stood at the far end of the long table, his notes arranged with meticulous care. Around him sat men who did not like surprises, generals, senior engineers, representatives of the strategic rocket forces, and two silent observers from the KGB. Behind Sokolov, a projector hummed to life. The first image was not dramatic. No explosions, no maps of targets. Just a schematic of the B-52's electronic warfare architecture, simplified for clarity. "This," Sokolov began, "is not a bomber in the traditional sense. It is a system of systems. Its strength is integration." He paused, choosing his words carefully. "And its weakness is the same." A murmur moved through the room. He walked them through months of testing, how the American radar could penetrate weather with frightening accuracy, how its jamming systems could confuse early-generation missile guidance, how layered redundancy allowed it to continue mission execution even with partial failures. Then he showed the other side. When one subsystem degraded, the workload on the crew increased exponentially. When two degraded, coordination slowed. When three failed, the aircraft did not become helpless. but it became predictable. This machine assumes time, Sokolov said. Time to diagnose, time to adapt, time to recover. He changed the slide. A graph appeared plotting mission effectiveness against system degradation. Our doctrine, he continued, does not give time. Silence followed. One general leaned forward. Are you saying the American bomber is inferior? Sokolov shook his head. No, Comrade General. I am saying it is optimized for a different war. In the weeks that followed, the conclusions were circulated under layers of classification. No public acknowledgement was ever made that a B-52 had been captured. Officially, the tests were labeled as Foreign Electronic Systems Evaluation. Unofficially, they altered Soviet thinking. Air defense planners adjusted engagement doctrine. Rather than attempting complete suppression, they focused on progressive saturation, forcing the bomber to rely on its systems until they became a liability. Missile crews were trained to stagger launches not for kill probability, but for disruption. The Americans, the reports concluded, fought to maintain capability. The Soviets would fight to remove it. Sokolov returned to Zhukovsky unsettled.
He was a pilot. He believed in machines that responded directly to human intent. The B-52 did not. It mediated intent through layers of electronics, procedures, and coordination. The crew did not fly it so much as manage it. One afternoon, he sat with a group of younger engineers assigned to study the captured avionics. One of them, barely 30, spoke with open admiration. Imagine what we could build with this level of technology. A bomber that never gets lost, that sees everything. Sokolov studied the young man's face. And imagine, he replied, what happens when it cannot see. The engineer frowned. Sokolov gestured toward the racks of components. This aircraft does not forgive ignorance. It demands specialists. It demands supply chains. It demands that war behave itself. War, Sokolov knew, never did. By autumn 1971, Soviet advisors in North Vietnam began quietly altering their recommendations. MiG units were instructed to coordinate more closely with missile batteries, not to destroy bombers outright, but to harass, distract, and force electronic countermeasures into constant use. The results were subtle but measurable. American after-action reports noted increased crew fatigue, higher error rates, confusion during prolonged missions, bombing accuracy degraded under sustained electronic pressure. No one in Washington connected these effects to a captured bomber in a hangar outside Moscow. But Sokolov did. He followed the reports obsessively. Each engagement validated his conclusions. The B-52 remained terrifying, but it was no longer unknowable. In December 1972, during Operation Linebacker II, the Stratofortress flew its most intense combat missions of the war. Losses were higher than expected. Crews reported systems behaving erratically under combined missile and fighter pressure. Sokolov watched grainy footage of missile launches over Hanoi in a secure screening room. He felt no triumph, only confirmation. That winter, Sokolov was summoned again, this time not to brief, but to advise. The Soviet Union was reassessing its own bomber force. Projects emphasized survivability through speed and altitude. But now, a new question entered the discussion. How much complexity was too much? Sokolov spoke cautiously. He praised American innovation, their ability to integrate systems far beyond Soviet capability. But he warned against imitation without understanding context. The Americans can afford this machine, he said. They can sustain it. They can replace its losses. We cannot assume the same conditions. One official scoffed. So we remain primitive? Sokolov met his gaze. We remain realistic. In early 1973, as the Paris Peace Accords were signed, the captured B-52 components were quietly archived. Some were used for training, others for reference. A few influenced Soviet electronic warfare designs in indirect ways. The bomber itself, the crippled airframe in Vietnam, was eventually dismantled under American bombing pressure. Its remains disappeared into jungle and scrap. But its shadow lingered. Sokolov wrote one final internal memo before being reassigned. The American bomber represents a belief in control of airspace, technology, and escalation. It is powerful because it assumes dominance. But dominance is temporary. When it fades, complexity becomes weight. He never published those words. They were filed, stamped, and forgotten by most, except him. Years later, walking past a Tu-95 on the flight line, Sokolov ran his hand along its rough metal skin. Loud, inefficient, endlessly reliable. He thought of the B-52's padded seats, glowing displays, and endless redundancy. Two giants, built for different truths. One assumed the world would bend, the other assumed it would break. And only one of those assumptions, he suspected, would survive the next war. 1974, Zhukovsky Airfield. Winter came early that year. Snow crept into every seam of concrete, every crack in metal. Colonel Viktor Sokolov stood at the edge of the runway, watching a Tu-95 Bear thunder into the gray sky. Its engines roared with a violence that felt almost prehistoric. The aircraft shook, clawed itself airborne, and disappeared into low clouds. It was loud, inefficient, impossible to ignore, and it would fly tomorrow. Sokolov had not touched the B-52 components in over a year. Officially, the program was complete, the data cataloged, the conclusions filed. Strategically, the captured bomber had already done its work. Personally, it still haunted him. The reassignment came quietly. No ceremony. No explanation. He was transferred from flight testing to doctrine review, a polite way of saying his days of influencing machines were over. Now he would influence words.
From his new office, he watched younger officers debate the future. Faster bombers, smarter systems, more integration. The American example loomed large, even when unspoken.
Sometimes, during late evenings, Sokolov reopened his old notebook. "Technology does not fail at its limits," he had written. "It fails when it is asked to endure." That sentence had never appeared in any official report. Across the ocean, the United States reached its own conclusions. Post-war analyses praised the B-52, its payload, its range, its psychological effect. Losses were framed as acceptable costs. The bomber would remain in service. It would be upgraded, modernized, digitized. Complexity would be refined, not reduced. Sokolov read translated excerpts of American journals with professional interest. He recognized brilliance everywhere, innovation without hesitation, confidence without restraint. He did not think them foolish. He thought them optimistic. In 1978, during a controlled visit to the Soviet Air Force Museum, Sokolov stopped before an exhibit rarely noticed by visitors, a small display case. Inside it, a single American circuit board recovered from Vietnam. No plaque explained its origin. To most, it was meaningless. To Sokolov, it was a fossil, a relic of a moment when two philosophies had touched without ever meeting. An engineer beside him remarked casually, "They built beautiful machines." Sokolov nodded. "Yes, beautiful." Then, after a pause, he added, "Beauty is expensive." Time passed. The Cold War cooled, then flared, then cooled again. New aircraft replaced old ones. Computers replaced gauges. Silence replaced roar. But one thing did not change. Every major conflict reinforced the same pattern. Weapons failed not because they were weak, but because they demanded conditions war refused to provide. In 1986, nearing retirement, Sokolov was asked to give a final lecture to a group of cadets. The topic was open. He chose not to speak about the B-52 directly. Instead, he told a story. He described two bridges. One was perfectly engineered, elegant, efficient. It carried immense loads, so long as every calculation held. The other was crude, overbuilt, ugly. It wasted material and offended designers. When the flood came, only one remained. The cadets understood. On his last day of service, Sokolov returned to Zhukovsky one final time. The hangars had changed. New aircraft stood where old ones once did. But the concrete was the same. The wind was the same. He paused where Hangar 12 had once housed the captured American bomber systems. Nothing remained. No crates, no cables, no evidence, only memory. He realized then that the B-52 had never truly been captured. It had delivered its lesson and left. Years later, after the collapse of the Soviet Union, fragments of classified archives surfaced. Historians pieced together hints, whispers of a bomber that landed where it should not have, of engineers who learned more than they intended. No official acknowledgement ever followed. The story remained incomplete, appropriately so. In the end, Sokolov's final note, found among personal papers, contained no references to nations or aircraft. Only this: endurance is not strength. It is humility made durable. He died quietly, without interviews, without memoirs. The B-52 still flies. So does the Tu-95. Two giants from another century, circling the edge of a future neither was built to understand. And somewhere between them lies the lesson both sides continue to relearn. War does not reward what is smartest. It rewards what remains.